so here's the answers for those ones. You can do these ones, especially the first ones are pretty easy doing the methods we talked about before. The other way of doing it is to put into your calculator. I'm okay with you guys doing that. I just want to show you a little trick if you are doing that though. In your calculator, if you look at like this bottom one, I don't know, 6.67 times 10 to the negative 11, the way you would put that in your calculator would be 6.67, and then you see this like EE, the two capital E's down there? That means times 10 to the, times 10 to the something. And so times 10, and then I go negative 11. And use that one, not this one. You can see there's like 10 to the x. A lot of people want to use that 10 to the x one. What that might do is confuse your calculator about like order of operations. So when you write it in your calculator like this with that capital E, your calculator knows that this whole thing is just one number, right? There's no chance of it getting confused. It knows that that's just some number that you put into your calculator. Okay, so that's my advice to you. The other thing I'd warn you about is just your order of operations here. So when you put this in your calculator, this bottom one, if you do that, I'd figure out what this was, and then I would divide it by all of this. So in your calculator, put brackets from end to end. If you don't, it's going to think that you're going to divide by the first one, and then it's going to think that you're multiplying by the second part here. So order of operations matters there. All right, so there's your answers. Take a second to pause, see if you got the right answer, and moving on. Okay, so there's your answer for number 7. Number 8, I just want to kind of help you get through this one. It says calculate how many meters there are in a light year, and that light travels at 3 times 10 to the 8 meters per second. So looking at units, this is saying that it travels this far, this many meters, every second. So we already know how many meters it goes in 1 second. So if we were able to know how many seconds there were in a year, we just have to multiply by that, right? So to figure that out, we are going to multiply by some factor. We want to change this, instead of meters per second, we want this in meters per year. So what I'm going to do is multiply by some factor here. And what I'm going to do is I'm going to put seconds on the top, because I want seconds to cancel, right? So if I multiply by this thing, my units are going to cancel like that. On the bottom, I'm going to put, well, I don't right off the bat know how many seconds are in 1 year, but I do know how many seconds are in, let's say, a minute. And I know how many seconds are in an hour. It goes 60 times 60. There are 3,600 seconds in 1 hour. Okay, so now if I do that, if I multiply by that factor, seconds will cancel with seconds. And now my units are in meters per hour. So that's going to tell me how many meters it goes in 1 hour. And I'm still not quite sure how many hours there are in a year either, but I do know how many hours there are in a day. So the next thing I'm going to do is multiply by, I'm going to put hours up top. I'm going to say there's 24 hours in 1 day. Now if I do that, if I multiply by 24, hours cancel with hours, and what I'm left with for units are meters per day. So I'm getting closer, right? I'm figuring out how many meters this thing goes every day. This thing, I mean light. Now last one, we want to get to years, right? So what I'm going to do is go, okay, well there are 365 days in 1 year. So now if I do that, days cancel with days, and now all I got to do is multiply all these numbers up top together, and I get 9.4, but I can't really go 9.4, can I? Because I only had one significant digit, my original one. So I'm going to say just 9 times 10 to the 15 meters every year. And that would be my answer. Okay, number 9 says, actually, by the way, number 8, if you found that really difficult, don't worry, we're gonna go over that a few more times for sure. Yeah, don't be too stressed out about that. We're gonna do more with light years in later unit 2, so yeah, I always wanted to give you guys a good chance to try these out. Number 9, a gold atom is 2.5 times 10 to the negative 10 meters in diameter. if you assume that the gold atoms line up in rows, about how many atoms would there be in a cubic centimeter of gold? So what we're really looking for here is volume. Okay, so what I've drawn here is just a square centimeter is what this represents. And it's saying how many of these, let's say these are like my little gold atoms, just going across. I don't want to draw them all, but let's say just across the bottom like that, right? So if I figure out how many are just across the bottom like that, that's going to be the same as the number going up this way. And it's also going to be the same as the number going this way, right? So as soon as we figure out what this number is, we just go length times width times height, and that's going to tell us how many atoms are inside that box. So first thing we got to do though is just, okay, so we know the diameter of our atom. We know that it's in cubic centimeter of gold. So I know that one of these sides is 1 centimeter. So what I'm going to do first is convert this centimeters into meters, because that's going to be better for doing our calculation. So we're going to go 1 centimeter is 0.01 meters. Okay, now all we got to do if we want to figure out how many of these gold things are along that bottom is just divide this. So I'm going to go this divided by the diameter I have. So let's do the calculation over here. I'll go 0.01 meters divided by 2.5 times 10 to the negative 10. And that's going to be 4 times 10 to the 7. There's going to be 4 times 10 to the 7 gold atoms along the bottom there. So 4 times 10 to the 7. And there's going to be 4 times 10 to the 7 this way and also up, right? So all I got to do now is go 4 times 10 to the 7 cubed, right? Just to the power of 3. So this is just going to end up being, actually I shouldn't have done that just to confuse you guys. So let's say that's what we had first. So now if I want the volume of this thing, so let's say is going to be equal to 4 times 10 to the 7 cubed. Okay, so then the volume, V, is just going to be equal to 4 times 10 to the 21. So that atoms. So I guess our units here would be atoms. That's a lot, eh? Okay, so that's number 9. I forgot to put 9 there. Okay, so for number 10, following measurements are made in the balance, which has a possible error of 0.01 grams for these measurements. So remember our formula for percent error is experimental minus predicted divided by predicted times 100. So the only thing to really know here to make sure you don't make a mistake on is that my experimental in this case would just be 700.01, right? Because that was what my possible error might be, right? It could only be 700.01, or it could be 699.99, right? Like it could also be the other way, so plus or minus that. So that's going to be what you get for that one. So that's my percentage error. It's pretty good percent. Yeah, so I'm just going to go ahead and write the answers down for B, C, and D for that one. Okay, there's your answers for 10. So just take a second to check to see if your answers were right. Okay, so number 11. On yours, you guys don't have this A, just as the second part, right? So yours just says the percentage error of each value. So don't worry about the percent difference for now. And that's just going to be done the same way, right? But just for each of those. So you're going to have your experimental and your correct value. So that's going to be, okay, so your two answers are 12.8% and 9.95%. And on your guys's, you don't have number 12 as well. I took that one off. So that's it. Hopefully that was useful. And we're going to start into lesson 1 next. So make sure you guys have a pretty good concept about this stuff, because it's going to be just required that you know a lot of these things now. Yeah, but that being said, we're going to work through these things quite heavily too in the next lesson. So, all right, so that's it, and I'll see you guys in the next video.